All right, welcome back. Picking up right where we left off on page 90 for the week 9 notes with question 314. Just a quick little review of what we ended with last time. I know this looks like a mess. You were with me when we did it, hopefully. Okay, so we are now using what we learned about factoring to solve equations. That was this piece right over here. So you always want to make sure it's equal to 0. You factor it, and then you tee it up. We'll do a lot more examples of that today. What we did over here on the right was learn how to graph a parabola. It was very, very simple. If you had your calculator, you just plug the equation into your y equals, pull up this table, and plot all of the points. This is one of the tougher parabolas you're going to have to graph. We'll do another couple of graphs today, just so you get the hang of it. Okay? But here's the parabola, and what you hopefully noticed was this, that we started down here. Your solutions for the quadratic were where your parabola crossed the x-axis. I know there was a lot of new words. Remember, a quadratic just means it has the x squared and the x. So these new types of functions, parabola is the U shape, and your solutions are where it crossed the x-axis. Now remember, this was your code word for the last video, so do not use that code word again. We're going to do another one in a little bit, okay? So moving right on to 314, okay? 3x squared minus 3x equals 10. We've got a big issue right here because it's supposed to be equal to 0. You can't start factoring until it is equal to 0. So how do we change this? I need to move that positive 10 to the other side. I am going to do so by doing the opposite to cancel it out over here and subtract it over. So I'm going to write minus 10 on both sides. Notice 10 minus 10 cancels, and now we are equal to 0, which is perfect. I can start factoring. But I need to write this out. This negative 10 does not combine to anything, so I'm just going to tack it on the end as 3x squared minus 13x minus 10. Now I move on to start factoring this. When I try to factor this, I see if it has a GCF first. It does not have a GCF among all 3 terms, so then I count them. I have 3 terms, so this is definitely going to be a trinomial. And in this case, because of the 3 in front of the x squared, it's going to be a trinomial AC. Unfortunately, I can't use the shortcut. So AC tells me my first step, I'm going to multiply A and C together. Notice that C is negative. So 3 times negative 10 is going to be a negative 30, and I list the factors of 30 off to the side. So this is going to be 1 times 30, 2 times 15, 3 times 10, and 5 times 6. Be careful with this one. We need to now pick the pair that adds to the middle number, which in this case is a negative 13. Take a couple of seconds to try and pick your number. Again, be careful. Hopefully, we picked the pair positive 2, negative 15. Positive 2 times negative 15 is negative 30, and positive 2 plus negative 15 is negative 13. If you thought it was negative 3 and negative 10, it is incorrect, because even though negative 3 plus negative 10 adds to negative 13, negative 3 times negative 10 is a positive 30, and that's not what we have. We needed to multiply to a negative 30. So this is AC. I can't use the shortcut. I've got to write this out. So I start my setup for AC by bringing down the 3x squared, splitting up the minus 13x into the 2 numbers I picked, so plus 2x minus 15x, and then the minus 10 comes down. And again, your equals 0 still there. You don't have to worry about it when you're factoring. You only want to look at this piece for the factoring aspect, and we'll add on that equals 0 at the end. All right, I set up AC so that it has 4 terms. My whole purpose in doing that was so that it can be done using grouping. So now in each group I need to take the GCF. My first group between 3x squared and 2x has a GCF of x, and I put that x out in front. 3x squared divided by x is going to be 3x. And then 2x divided by x, my x's cancel and leave me with a plus 2. In my next group, negative 15x and negative 10, I need them to be positive so that they match up over here. So my GCF is going to be negative, and between negative 15 and negative 10, my GCF is a negative 5. So my negative 5 comes out in front, and then I divide. Negative 15x divided by negative 5 is a 3x, and negative 10 divided by negative 5 is a plus 2, and luckily they match up. Remember what we do after they match. You bring down the matching factor, 3x plus 2, and those go away. Then you take your two GCFs and you put them together, x minus 5. Now I'm done factoring because neither of those can be factored again, but I need to remember to now bring down my equals 0. If the directions on a test or a quiz said factor, we would be done right now because we've done what we were instructed to and we factored. But the directions for this problem are to solve. So I need to do that next step. This at the bottom right here, tee it up. So if you don't remember what we did in the last video, to tee it up, you draw a vertical line to split up your two factors, and then you draw a line underneath them, essentially drawing yourself a T. Now underneath each side of your T, you set that piece of your answer, of your factoring, equal to 0. So on the left side, I have 3x plus 2, so I'm going to write 3x plus 2 equals 0. On the right side, I have x minus 5. I'm going to write x minus 5 equals 0. Now what we just did here is we took a quadratic, we factored it into two solvable factors, set them equal to 0, so now I can solve those equations. So on the left side, to get x by itself, remember you always get rid of what's being added or subtracted first, so I'm going to subtract the 2 from both sides, so that those 2's cancel, and then 3x equals comes down. 0 minus 2 is a negative 2. Now I divide by 3, so those 3's cancel, and I get x equals negative 2/3. It's not a nice decimal, so you want to leave that one as a fraction. If you wrote the decimal, it would not be wrong. Okay. For the right side, a lot easier to get x by itself. I just have to get rid of that minus 5, so I add 5 to both sides, and I get x equals 5. So these are my two answers. Remember what I told you in the last video? If you look at my answer keys on Blackboard, you're going to see it written like this. It's called a solution set. It's just stating both of your factors in a solution set, but this is absolutely correct if you don't write this. It's no big deal. All right, now I would love to review another graph with you. This graph does not turn out very nicely, so what I'd rather do with you so we can just move on to some other algebraic examples is show this part right here, this super main idea you need to comprehend. Your solutions are where the graph crosses the x-axis. So my graph is going to cross at positive 5 and at negative 2/3. If you're not familiar, plug in 2 divided by 3 in your calculator. I know I said to avoid the decimal, but this is the essentially negative 0.6. 0.6 is about here. So those are two crucial points you would notice on your graph had you graphed this whole thing. I will walk you through it, but I just want to warn you, this is not a great example, so if you think it'll confuse you, don't stress about it, okay? So to graph this in your calculator, we have to take what we were given and plug it into the y equals. So you're going to be typing in y equals 3x squared minus 13x minus 10. So to graph this function on the calculator, we have to plug it into our y equals, which is exactly like we did in the last video. So I go to that y equals, clear everything out, and we're going to type it in exactly how we just wrote it. So 3x squared minus 13x minus 10. Now just a reminder, you can press that graph button to give yourself an idea of what your graph should look like. You can play around with the window. Hopefully you still have the same window that we had in the last video. Yours will look exactly like my screen does. If not, remember you can zoom in or zoom out or play with that window to get your x-min, x-max, y-min, y-max to match the axes that we have scaled on the notes. So again, this is just a picture of what your graph should look like to kind of make sure you're doing it correctly, but ultimately you need the points. So you're going to go second graph, and that'll pull up a table, and you'll be given this list of points. Now you only want to choose, or to use, I should say, the points that are plottable. So that first point on my table right now is -2, +28. I know that the y max on my y-axis is a +2. So there's no way I can plot a 28 if my grid only goes to a +2, so that's too big. I look at the next point. -1, 6 is much closer, but 6 is still just a hair too big because, again, my y max is 2. So the next point, 0, -10, is the first plottable point on this graph. 0, -10 is plottable. I'm going to plot it at 0 on my x-axis, or I'm sorry, starting right here at 0. Then I'm going to go down to -10. So this point right here, when x is 0 and y is -10. Then I'm going to plot 1, -20. So I go to 1 on my x-axis, down to -20 on my y-axis, and I keep going just like that. 2, -24. And 5, 0 we already have plotted, which is nice. Okay, once you're done plotting those points, draw your U. Remember, it should be curved at the bottom. Again, I made it very sloppy. I'm doing my best over here. Arrows at the end, because even though we can't see the graph, it does continue up. Okay, if you need more time to graph it, absolutely pause at this point. I want to draw your attention to the last graph we did. Hopefully you noticed this pattern right here, whoops, where these were on the same line. These matched up, 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 and then you had a point down here in the center at the bottom. This graph, like I said, it's an uglier graph. You're not going to see one like this again. It's always going to match up, so you will have this kind of pattern for every parabola going forward. This one's just a little sloppy. The biggest thing I wanted you to get out of the graphing process for this question was plugging it into the y equals on your calculator, finding where this table is, and knowing that this and this are your solutions. All right, so moving on to a couple odd questions. 315 says x squared plus 4 equals 0. What do you notice? Provide a sketch of the graph to help. You can plug this into your y equals as y equals x squared plus 4 and take a look at what it looks like. Because it's just a sketch, I'll show you exactly what it looks like. You'll notice there's a point here, and then it just goes up from there. Okay, so again, graph it if you want to. Take a pause, hit second graph, and start plotting some points. But again, it's just a sketch, so you just kind of want to see what it looks like. And I want to draw your attention to this. This is your x-axis. Remember what we talked about in the last two examples, one in the first video and one in this one. Your solutions are where the graph crosses the x-axis. This graph doesn't cross the x-axis, so that means that there are no real solutions. Okay, because it never touches the x-axis. Now that word real, no real solutions, is nothing you're going to have to worry about in this course, but if something doesn't cross the x-axis, it doesn't mean there aren't any imaginary solutions. There's a whole concept in math about imaginary numbers, which again, we are not going to dig into. You might dig into it in the future, which is why I just wanted to make sure you all know that this not crossing the x-axis means there's no real solutions. There's actually two imaginary solutions for this one. Now, something I want you to notice about this algebraically, if you tried to solve this by factoring, you would look for a GCF first, and there isn't one. Then you would count the terms. There's 2, which normally goes with DOPS, difference of perfect squares, but this one doesn't have subtraction, so we can't even factor this one. So you can't factor it, there's no solutions, just nothing works, okay? All right, this next one also kind of an oddball. I have x squared plus 6x plus 9. It says, what do you notice? I want to start factoring this one first. So we're going to factor this piece of it. There's no GCF, so I count my terms. I have 3. So this is a trinomial, and it is an easy trinomial because of the 1 in front of the x squared, so I can use the shortcut. So off to the side, I need to find the 2 numbers that multiply to 9 that also add to the middle number. So my factors of 9 are 1 times 9 and 3 times 3. Of that list, I need to pick the pair that adds to 6. That's definitely going to be a positive 3 and a positive 3. So using my shortcut, I'm going to write out x plus 3, and at this point I'm going to bring down that equals 0. Now, to solve this, I know it doesn't say to solve, I want you guys to solve this just to see what it's going to look like on the graph. You would tee it up, and on each side, set that factor equal to 0. Now, what I'm hoping you notice is when you go to solve each of these, you're going to subtract 3 from both sides, and you are going to get an answer of x equals -3 for both of them. This is what's called a double solution. You really only have one answer. If I were to put this in my squiggly wigglies, which you don't have to, you'd only list it once because there's only one answer. So you can absolutely plug this in your y equals in your calculator to see the graph. I'm just going to show you what it looks like. Since we know our solution is -3, that means it's going to cross the x-axis at -3. But it's only going to touch it once. It's not going to do what these other graphs did where it hit it once and then it came back up and hit it again. Okay, this one's just going to hit it that one time, like so. And again, that's just a sketch. That's not exactly what it looks like. Honestly, I think the graph's a little bit wider, but this is the important part. It crosses the x-axis at -3. That's what I want you to notice. It only touches once. The one before it didn't touch at all, and other ones, like the last two that or the first two that we did, touched it twice. So those are your 3 different scenarios you can have when graphing a parabola. Okay. Diving away from graphing, again, just for a little bit, we're going to practice more with solving. So again, when you are solving a quadratic, or anything that has an x squared, an x, maybe an x cubed, it's got 2 different x terms. You have to factor. You can't start factoring until it's equal to 0. So I'm just going to draw this over here for you, like a little thing you need to remember. It needs to be equal to 0 to start. Then you factor, then you tee it up. So again, get it equal to 0, factor, tee it up. Okay, so for 317, I've not set up correctly. I've got to get it equal to 0 first. To do that, I need to move that positive 14x squared to the left side. I'm going to do so by doing -14x squared to both sides. So this cancels. Notice where I put the -14x squared. On the left side of this equation, I have an x cubed and an x. There's no x squared to combine it to. When you bring it down, it has to be in standard form, which is highest exponent to lowest exponent. It's all about the setup to help you with factoring. It ultimately will end up being in ax squared plus bx plus c form, but for now I'm going to have a GCF. You'll see it come out a little bit later. So highest exponent is 2x cubed my next highest exponent is going to be that -14x squared, and then the plus 20x comes down, and then my equals 0. If you didn't set it up like that right off the bat, you'd notice it's wrong in the future. I'll bring that up to you once we get there, but for now, just try and get in the habit of doing highest exponent to lowest exponent. All right, at this point, I'm ready to start factoring this. You always want to see if it has a GCF first, and this one does. Okay, my GCF for this is going to be 2x. All three terms have an x in common, and 2 is the biggest number that can be taken out of all of them. So I start by dividing all three terms by 2x, and I put that 2x out in front in my next step. And then divide. These 2's cancel or just leave me with a 1. X cubed divided by x is x squared. Negative 14 divided by 2 is a minus 7, and x squared divided by x is x. And then 20x divided by 2x is going to get me a plus 10 because those x's cancel out. Again, while I'm factoring, you don't have to worry about that equals 0. We'll just bring it down towards the end. Now I'm going to add a little word up here that's really important. We have to factor completely. Sometimes that's only factoring once, like the last 2 examples we did. Sometimes it's further, okay? So this one we actually can factor again. X squared minus 7x plus 10 has 3 terms, so that tells me it is a trinomial. And luckily, this one is a trinomial easy because of the 1 in front of this x squared here. So I can use my shortcut. So off to the side, I'm going to write a 10, the number by itself, and list the factors of it. 1 and 10, and 2 and 5. Keep in mind, multiplying to a positive 10, I can either do positive times positive or negative times negative. In this case, it's going to be negative times negative because I'm trying to add to a negative 7. So my pair is going to be negative 2 and negative 5. And again, I'm lucky I can do the shortcut for this one, so my factors are just going to be x minus 2, x minus 5, and I'm going to remember to bring down this 2x. Now, I can't factor this anymore, so I'm going to go ahead and bring down that equals 0. So there's a reminder about one of my students at high school. Okay, so the 2x came down, my equals 0 came down because I can't factor this anymore. If the directions told me to factor, I'd be done at this point, but it says to solve. Well, it should say to solve. It says way up at the top that we are solving. Okay, so that means I have to do this right here, tee it up. Now you'll notice I don't just have 2 factors anymore. I have 3. I have this 2x, I have the x minus 2, and I have the x minus 5. So you are going to tee it up like you normally would, but you also have to split these up. I call this a double T because you end up with 2 t's at the end. You always draw a vertical line through all of your factors. So 2x and x minus 2 and x minus 5 are 3 different factors, and I had to tee up each one. Now underneath each part of the t, I'm going to set it equal to 0. So on this far left side, I'm going to have 2x equals 0. In the middle, x minus 2 equals 0. And on the right, x minus 5 equals 0. It just means I have 3 equations to solve now, which also tells me I'm going to end up with 3 answers. So to solve this first one, to get x by itself, I need to get rid of that 2 that's being multiplied to it. To undo multiplication, I divide, and 0 divided by 2 is 0. So one of my answers is 0. X minus 2 equals 0 means I'm going to add the 2 to both sides to get it over and get x by itself. And I get an answer of x equals 2. And then to undo this minus 5, I'm going to add 5 to both sides, and I get an answer of x equals 5. Now you might be curious what this graph looks like. This one was actually not a quadratic to start. Notice it was x to the 3rd power. If you want to graph it, you would just type this into your y equals to see what it's going to look like, but it's a cubic function, which just means it's x to the 3rd power. It's not going to look like that U-shaped graph we've been doing. That's only when you have a quadratic, like this next one and the one after that. When you have an x squared, you're going to see that U-shaped graph. This one, you're not going to graph anything like it in this class, which is why I didn't want you to worry about it, but that's why there's 3 answers. So this one just crosses the x-axis at 0, 2, and 5. Your 3 answers. All right, let's solve this next one. For 318, remember what I bubbled in up here. You first need to be equal to 0, and this one is not. So I have to move that negative 4 to the left side, and I'm going to do so by adding it because negative 4 plus 4 cancel out. Now again, I need that ax squared plus bx plus c format. So my 16x squared comes down first, then minus 16x, then that plus 4 gets tacked on the end, equals 0. Okay, first thing I check for is the GCF. This one has one, so I'm going to do my GCF factoring first. The GCF between all three of these terms is a 4. So I start by dividing all three terms by 4, and I put that 4 out in front. There's a lot involved in this question, so please stick with me. Okay, 16 divided by 4 is a 4. The x squared comes down. Negative 16 divided by 4 is a minus 4, and the x comes down. And then 4's cancel, but you have to replace it with a 1. Or just think of it as 4 divided by 4 is 1. And I'm going to leave that equals 0 off until the end. Now I've done GCF. I did a great job. We factored perfectly, but we're not factored completely. I have to now look inside the parentheses here to see if it can be factored again. So I count the terms. I have 3, and there's a 4 in front of the x squared, which tells me it's trinomial AC. Unfortunately, I can't use the shortcut, but AC gives me a hint of my first step here. A times C is going to be 4 times 1, which is 4. So my factors of 4 are 1 and 4 and 2 and 2, but I need to pick the pair that adds to the middle number, which in this case is a negative 4. So think about it. You have to multiply to this positive 4 over here and add to a negative 4. It's a lot of 4s. Just try and keep your brain organized a little bit here. It's going to end up being 2 and 2. Now 2 times 2 is positive 4, but 2 plus 2 is not negative 4. The only way this works is if I make both of these negative, and it still works for multiplying. So negative 2 times negative 2 is positive 4, and negative 2 plus negative 2 is negative 4. They all check out. I can't use the shortcut, so I have to do my giant setup and then end up doing grouping. Now, if you remember, the first example we did like this on the last video, this GCF has nothing to do with that grouping and AC factoring I'm going to be doing. So I'm just going to draw an arrow to remind myself to bring it down at the end. Now I set up AC. Bring down your first term, which is 4x squared. That middle term of minus 4x is going to split up into minus 2x, minus 2x. I'm just going to erase this 4. It's going to end up being in the way. I didn't move it down enough. And then my plus 1 comes down. I have 4 terms. The reason I made them have 4 terms is so that I can do grouping. So I put 2 groups together, my first 2 terms in the first group, my second 2 terms in the last group, and then I have to GCF each group. So my first group has a GCF of 2x, so I'm going to divide by 2x for both of them, bring that 2x down, and divide. 4x squared divided by 2x. First, 4 divided by 2 is 2, and x squared divided by x is x. And then here, everything cancels, and I'm left with a minus 1. Now, when I go to take the GCF out of my second group, I notice it doesn't really have a GCF, so my GCF is going to be 1. But I need this negative right here to become a positive so that these match up. So my GCF needs to be a negative 1. So I bring that negative 1 down, followed by parentheses, and hope that these match up. Negative 2x divided by negative 1 is a positive 2x, and positive 1 divided by negative 1 is a negative 1, and this does match up with this. So remember what you do after that. Once they match up, you bring it down, 2x minus 1, but you only bring it down once, so those are gone. And then this is kind of weird, but 2x and negative 1 is what's left, so those come together, and I end up with the same factors. That's okay, nothing wrong with that. Now, remember, this arrow is here for a reason. You bring down that 4, and you are done factoring. We're not done solving. So at this point, now that I've finished factoring, I'm going to bring down that equals 0, and I go back up to my steps. Remember, we had to set it equal to 0, which we did. We had to factor it completely. Now we have to tee it up. And again, just like the last example that I did, 317, I have 1, 2, 3 factors. So I need to do that double T again. So I'm going to split it up here and here and set all 3 of them equal to 0. So on this left side, 4 equals 0. In the middle, 2x minus 1 equals 0. And on the right, 2x minus 1 equals 0. Now remember, the ultimate goal here is to solve for x. On this left side of my t, there's no x to solve for. This is my favorite part. Bye! If there's no x to solve for, you don't worry about the math on it at all. It's just gone. Now, these next two. To solve for x, you have to get rid of what's being added or subtracted first. So I'm going to start by adding 1 to both sides so that those cancel. My 2x comes down, and that's equal to 1. And then I divide by 2, and I get x equals 1/2. Now I will show you, but you absolutely don't need to do this. Because these factors were identical, solving this next one, I add 1 to both sides, I get 2x equals 1, and then I divide by 2 and I get x equals 1/2. Again, it's that double solution, so you only have one answer, and that's 1/2. So this would be one of those weird situations where you graph it and it only crosses the x-axis once. All right, next example, 319. Nice setup. It's already equal to 0, which is awesome. I don't have to worry about that first step. My setup is perfect. All I have to do now is start factoring it, and I'm trying to factor this completely. So first thing I'm trying to look for is a GCF. This one has one. My GCF here, take a second to try and figure it out. It's 2. So I divide both of them by 2, and I put that 2 out in front. 2x squared divided by 2, your 2's cancel or just leave you with a 1. Ultimately, it's just going to be x squared or 1x squared. And then negative 32 divided by 2 is a minus 16. And again, I'm factoring for now, so I'm going to ignore that equals 0. I'm just looking at the factorable part. And you want to see if it can be factored. Again, you always want to be factored completely. This one can. If you look at what's left in the parentheses, it is 2 terms, which is typically DOPS, and it is in the DOPS setup. I have the subtraction of perfect squares, so I do the square root of each of them, which I'm just going to write off to the side. The square root of x squared, what times itself gets you x squared? That's going to be x. And the square root of 16, what times itself gets you 16? That's going to be 4. And recall your setup for DOPS. It's the same every time. 2 sets of parentheses, one with a plus and one with a minus. And you just fill in the blanks. This one's going to be x plus 4 and x minus 4. Now don't forget, at this point, you want to bring down that GCF. It is part of your factoring. And I'm going to bring down the equal 0 because this will not be factored again. I've already factored twice. Now, same idea as the last 2 examples. I have 3 factors here, so I need to do my double T. I'm going to draw a vertical line to split all of them up, and then the horizontal line underneath them. Now, within all of my sections of the T, I'm going to set them equal to 0. So 2 equals 0, x plus 4 equals 0, and x minus 4 equals 0. Now, think for a second. What's going to happen with that 2 equals 0? It just happened in the last example. Hopefully you did that. There is no x to solve for, so there's nothing to do with it. It's gone. It's out of the way. Nothing to solve there. Now these 2 factors, even though they look very similar, they're different and they're going to yield different answers. So the first one, to get x by itself, I subtract 4 from both sides. X equals comes down, and 0 minus 4 is a negative 4. That's one of my answers. This next one, x minus 4 equals 0. I'm going to add the 4 to both sides, and I get x equals a positive 4, my second answer. So for this one, my 2 answers are negative 4 and positive 4. And remember, you don't need to put them in the squiggly wigglies. You might also know them as curly brackets. You can just leave them like this. That's perfectly fine. Because notice, it's the same steps every time. Get it equal to 0. Factor completely, tee it up. So this next one, whoopsie, is already equal to 0, which is awesome. I don't have to worry about the setup. I can jump right into factoring this. So the first type of factoring you always look for is GCF. And this one also has one. Take a second to try and figure out on your own what it's going to be. Don't get overwhelmed with the 162. Think about that smaller number. The only numbers that go into 2 are 1 and 2. So the biggest number that goes into 2 is 2, and luckily 2 goes into 162 as well. So, whoops, I don't know why I wrote a 6. Oh boy. My GCF is going to have a 2 in it. And then don't get overwhelmed with that x to the 5th either. Remember, x to the 5th just means there's 5 of them. But there's only 1 here, so they only have 1 in common. So my overall GCF is going to be 2x. So I start by dividing by 2x, dividing by 2x. And remember, that equals 0 has nothing to do with it for now. We're only factoring this piece right here. So the 2x comes down, followed by a parentheses. These 2's cancel or leave me with a 1. And x to the 5th divided by x, using that same idea that there's 5 x's on top, 1 on the bottom. So only 1 cancels on the top and the bottom, and I'm actually left with 4 of them. So x to the 4th. Negative 162 divided by a positive 2 is going to be negative 81, and those x's just cancel out. So I factored once, I did GCF. I want to see if I could factor what's left in the parentheses again. So x to the 4th minus 81 is 2 terms, which typically goes along with DOPS, but you have to make sure it's the correct setup for DOPS. So I have subtraction. 81 is a perfect square, and x to the 4th is also a perfect square. It has an even exponent, so I'm absolutely going to do DOPS. So the square root of x to the 4th, or in other words, what times itself gets you x to the 4th, is going to be x squared. And what times itself gets you 81, that's going to be 9. And your setup for DOPS is always the same. 2 sets of parentheses, one with a plus, one with a minus. So I end up with x squared plus 9 and x squared minus 9. And don't forget to bring down the 2x. Now before you bring down that equals 0, I know I told you on tests and quizzes you're only going to have to factor twice in one problem. We've done GCF and we've done DOPS, so on a test or a quiz you would never have to go further than this. This example is kind of a challenge problem, like something you might see on a bonus. I just wanted to give you some insight on what that might look like. You can actually factor this again. So the 2x can't be factored again. I look here. X squared plus 9 has 2 terms. Generally with 2 terms, it goes along with DOPS, but this one's not a difference, so I can't do DOPS to this. However, right here, again, 2 terms, it has the subtraction, and those are perfect squares. So this is an example of one that could be factored 3 times. I'm going to do DOPS again, but only to the second one. So I'm going to take the square root of x squared and the square root of 9 off to the side, and the square root of x squared is x. The square root of 9 is 3. Okay, so my setup for DOPS, 2 sets of parentheses, one with a plus and one with a minus. I'm going to get x plus 3 and x minus 3. Now, these 2 pieces in the beginning could not be factored again, but they are still part of our factoring, so they're going to come down. Now, I cannot stress this enough. You will never be given an example this difficult on a test or a quiz, but this one has 4 factors, so it's like a triple T, I guess. You split up all of your factors with vertical lines, draw the horizontal line underneath it, and just don't forget to bring down that equals 0 now that we're done factoring. Underneath each section of the T, set that equal to 0. So 2x equals 0. X squared plus 9 equals 0. X plus 3 equals 0, and x minus 3 equals 0. And we need to solve each one. On the far left, this one does not cross out. There is an x to solve for, so it's not like the last example over here where I completely crossed it out and there wasn't an x. This one has an x to solve for, so I'm going to solve for the x. To get x by itself, it's being multiplied by 2 right now. I'm going to divide both sides by 2. 0 divided by 2 is 0, and that's going to be one of my answers. Next one, I want to skip for a second and bring you over to the next one. To get x by itself here, I undo plus 3, so I subtract 3 from both sides, and I get x equals negative 3. And this last one, to get x by itself, to undo minus 3, I add 3 to both sides, and I get x equals positive 3. If you understood that, phenomenal. It was already harder than it was going to be. This next one that I skipped over solving is going to be even more challenging. So please just stick with me for now, okay? So to get the x by itself, I have to first get rid of that minus 9, or that plus 9, because you always get rid of what's being added or subtracted first. And I'm going to do so by subtracting the 9 from both sides. So x squared comes down, your equal sign comes down, and 0 minus 9 is a negative 9. Now, you may or may not remember this, but the opposite of squaring something is square rooting something. So to get rid of that squared, just like you solve for any x, you always do the opposite. You're going to get rid of it by taking the square root. If you don't follow me with this, don't stress about it, okay? So the square root of x squared is going to get me x. It gets rid of that squared. The square and square root cancel completely. Now, the square root of negative 9. When you're taking a square root, you're asking yourself, what times itself will get you that number under the square root? So what number times itself will get you a negative 9 is actually impossible. Okay? You might be thinking 3. 3 times 3 is a positive 9. If you're thinking negative 3, negative 3 times negative 3 is also a positive 9. It is impossible to multiply a number by itself to get you a negative. That doesn't mean there's not an answer. It means there's not a real answer. The way that this would be written is 3i. Remember those imaginary numbers I told you we wouldn't be worrying about? Okay, you're not going to worry about it, so don't worry. This is just a really good factoring example of what it looks like to have to factor 3 times. This part right here that you hopefully understood is all you need to understand for this course. If you're digging into imaginary numbers in the future courses that you might need to take for math, this is definitely something for you to just kind of breeze on for now. And again, just because I'm particular, it's going to be a plus or minus 3i, because it could be a positive 3 or a negative 3 imaginary number to get you that negative 9 under the square root. Okay, don't worry. Did you ever hear, don't worry, be happy, it's all good. All right, one last example, but before we do, we're going to do code words. Your code word for today is brownie. Brownie, because I'm hungry. All right, and before we dig into this, just one last thing I'd like to show you with this example. It would cross the x-axis 3 times. You don't see imaginary numbers on the x-axis. So that last example only would have touched the x-axis 3 times. Okay, code word brownie, and here we go with our last example. So it's functions and modeling. We're supposed to put some real-world scenario into all these things that we've been doing. So here we go. 321 says a rocket is fired upward following a path given by y equals negative 16x squared plus 112x, where y represents the height in feet above the ground and x represents time in seconds. So do what you got to do to underline that for yourself. Y is height, x is time. So as you go further on your x-axis, your path that your rocket is taking is going to be shown using height as a reference. Okay. Part A says determine the initial height of the rocket. So when it's asking you to find height, it's saying find y, but it wants the height at the initial starting point. If you're trying to find y, that means you need to plug in an x. Think about what x would need to be plugged in if you're just starting. Initial means that x is 0. So in that equation we were given, everywhere you see an x, you should plug in a 0. So negative 16, instead of x squared, I'm going to write 0 squared, plus 112 comes down times x, but in place of x, again, I put in a 0. So hopefully we can do some quick math. Math's real nice and easy when you have zeros. All those are going to end up zeroing out. Negative 16 times 0 squared is 0. 112 times 0 is 0. And 0 plus 0 is 0. So what that tells me is that the initial height of this rocket is 0 feet. So basically it's on the ground. So my rocket is starting at 0 seconds and 0 feet. Next one's a little bit tougher. Determine algebraically how many seconds it takes for the rocket to reach ground level. So now it's asking me how many seconds. It's saying to find x, because remember, I go back up here, it tells me x is time in seconds. So how many seconds means I need to find x. And I have to figure out how many seconds it takes for the rocket to reach ground level. Ground level is a certain height. Height is my y value. It's telling me that y is on the ground, or in other words, where y is 0. Now, you might be thinking that's a stupid question because we kind of just answered that in part A, and you might be right. You're partially right, I should say. When we are at 0 ground level, it's at 0 seconds. So you're thinking your answer should be 0 seconds, but what comes up must come down. The rocket is absolutely going to start at 0. 0 seconds is going to be one of your answers for this, but then it's going to come back down and it's going to hit the ground at a certain value. That's what we need to figure out as well. So what I'm going to do is put y equals 0 in my equation. So I'm going to put a 0 right here. So it's going to be negative 16x squared plus 112x, and I'm going to set it equal to 0 instead of equals y like it was given originally. I'm just plugging in 0 where I see a y. Now I know the 0's in front here. I just flip-flopped the sides of the equation because it makes more sense to see the 0 on the right side. That's where you guys are used to seeing it. Now notice what we have here. We have an equation with an x squared and an x, so it must be factored to solve it. Before we get into what type of factoring, remember what you're supposed to do to solve something like this. First set it equal to 0, then factor it completely, and then tee it up. So luckily this one's already equal to 0, so we are good to go. I just need to, factor it completely. First type of factoring you look for is a GCF. This one has one. So I'm going to state my GCF off to the side. Take a second to try and figure it out. This one's a little bit bigger than we're used to. Remember that shortcut I told you guys? Look at the smaller number. 16 is the smaller number. Think about the factors of 16. The biggest number that goes into 16 is 16. If 16 also goes into 112, it's going to be your GCF, and it does. So my GCF is going to be 16, and they also have an x in common. Now, take my word for it for this one. Let's make it a negative 16x. Okay, you'll see why once we get to it, but negative 16x. So I'm going to factor this using my normal GCF factoring, taking out a negative 16x and putting that negative 16x out in front. Here's why it's nicer to divide by negative 16. These cancel completely. I don't have to worry about a positive or negative sign. It's just gone. If you did a GCF of positive 16x squared, you would absolutely not be wrong. It's just kind of nice when things cancel out like that. So these x squared divided by x is what's left, and that leaves me with an x. Then I do 112 divided by negative 16, and I get a negative 7 when I do that, and these x's cancel. And if you look, I've actually factored completely. X minus 7 can't be factored again, so this one only factored once, and that's fine. My equal 0 just comes down. Now, I factored. I need to tee it up. I have two factors here, so I'm going to draw a vertical line through them, and then a horizontal line underneath. And on each side of my t, I'm going to set that factor equal to 0. So negative 16x equals 0, and x minus 7 equals 0. Okay, and then I solve each of them. So on the left, it doesn't cancel out because I can get x by itself. I divide by negative 16, and I get x equals 0. Remember, we talked about that. X equals 0 was supposed to be an answer because it started on the ground at 0 seconds. We figured that out in part A. But here's where my other answer is going to come in. To get x by itself, I need to move that minus 7 over. The opposite of minus 7 is plus 7. So I add 7 to both sides, and I get x equals 7. So yes, it is at ground level at 0 seconds. We already knew that. Look at the wording in the question. It says determine algebraically how many seconds it takes for the rocket to reach ground level. So your rocket is going to start at the ground. It's going to come up and it's going to come back down at 7 seconds. So your answer to this is 7 seconds. That's how long it takes for it to reach ground level again. This is fun how things are just popping up in this video. Good stuff. All right, we're going to go over graphing. One more example. So part C says graph this right here, y equals negative 16x squared plus 112x below. So what I'm going to do is grab my calculator. I'm going to clear it all off so we can start from scratch. Okay. When you use your calculator to graph something, you have to hit the y equals button, even though this one, actually I think it does say y equals. It does. So you just hit your y equals button and you go and type in exactly what your equation says. So once you hit y equals, you'll see it at the top of your screen. You are going to type in negative 16x squared, remember your x button's right here, plus 112x. Once you type that in, you hit second graph to pull up your table. Now, dig around your table to try and find the values that will fit on this grid. You have a bit of a problem. This grid does not have its axes labeled. There's no numbers on the x-axis or the y-axis, so it's kind of hard to know what you need to graph. And I don't want you to write this, but I do want you to notice where your axes are. Your origin, or your 0, 0, is right here. Remember, don't make yours sloppy. Don't draw this in. I'm just trying to draw your attention to what I'm showing you in red. Your origin is right here, which is 0, 0. Everything to the right of that is going to be positive, and everything above that is also going to be positive. So that being said, if everything is positive on this graph, you can only plot positive numbers. If you look anything higher than 0, 0, this point that I have first on my table, includes negative numbers. It's not plotable. So again, if you're wondering how is she figuring out which numbers to choose from the table, it's just numbers that are plotable. Anything positive. Now, there are 8 points on my table. I want you to copy them down real quick, or at least scroll to that section of your calculator. Those are the only plottable points. So you copy them all down. Now we're going to get into scaling. Your x-axis. Look at the x's in the table. We have all x values from 0 through 7. Oh, I got a hiccup. This is all fun. So for 0 through 7, I need this x-axis on the bottom to be scaled from 0 through 7. If you count it using a scale of 1, so like 1, 2, 3, 4, 5, 6, 7, you're not going to use much of the grid space, and it's actually going to be harder to plot. You want to try and spread your numbers out as best as you can. This one actually works out perfectly if you go every 4 boxes as 1. So every 4 boxes is just increasing by 1 value. Again, you would not be wrong if you counted up each one box as 1 value. But your graph is going to be squished in this little section over here, and it's a lot harder to graph when you have a smushed graph. If you're able to spread it out as best as you can. Even if you just want to use every 2 boxes or every 3 boxes, spreading it out will help. So take a second to scale that out. Okay, now your y-axis is going to be a little bit more challenging. So look at the y column on your table. Okay, the y column on your table, whoops, can't scroll up I guess, has a low value of 0, and we already know we're starting at 0. 0 is right here in the corner. but the maximum y value that you need to get to is 192 at least, okay? So when I'm scaling this, there's no way I can go 1, 2, 3 and make it all the way up to 192. So what you may or may not notice, it's actually kind of nice for this, is all of those y values are multiples of 16. So you can count up each individual box by 16s. You want to count by, like, so the thought process here, like I just showed you, ones aren't going to work. You could try 2s, 2, 4, 6. It's not going to fit. You want to figure out something that you can count by, that's nice to count by, that will ultimately fit on these limited amount of boxes that you have to scale it by. So if you looked at my answer key already, I counted up by 20s, and you absolutely can. 20, 40, 60, and so on with each tick mark. But what I'm trying to show you is 96, 160, and 192 are all multiples of 16. So if you count up by 16s, it'll be much nicer for you to graph in the end. So scaling, it's going to be kind of yucky, but graphing will be nice because the values you're looking for will already be there. So you can just copy mine, or you can keep adding 16 in your calculator if you want to. So 64, then 80, 96. There's my first number that I was looking for. 96 matches over there. Then 112, which isn't there, but that's okay. Then 128. So again, see how it fits now? Because I counted by 16s, I had enough boxes to spread that out so that I can get up to my maximum of 192. I'll even go one higher, above 192, which is 208. You don't have to, just a little extra. Okay, remember, this is your time in seconds, and this is your height in feet. Just to put some perspective to the graph and what's going on here. So if you need more time to scale your axes, pause the video. I'm going to walk you through actually plotting these points now. So the first point is the point 0, 0. That one's real easy to apply. It's right here on the corner when x is 0 and y is 0. Your next point is 1, 96, which means after 1 second, it was at a height of 96 feet. I believe it was feet. Yeah, feet, wow. So 96 feet after 1 second. After 2 seconds, so I go to 2 on my x-axis, it was at a height of 160. So 2, 160. See how it's kind of nice when it's all spread out? When you have the exact numbers over here, if I counted by 20s, 160 would be there. But 96 wouldn't have been. I would have had to scale it to figure out where it would fit. It'd be close to 100, but not quite there. It's just nicer when you have the exact numbers. Okay, my next point is 3, 192. So I go to where x is 3 and y is 192, and so on. Oops. And notice, like I told you guys before, all of these match up. It's kind of got this pattern over here where 96, 160, and 92 all match up. So it makes a nice parabola. Once you're done, remember it's supposed to be U-shaped, even though this one is an upside down U to follow that rocket path. You still want a curve up there at the top to make it U-shaped. Okay, so if you need more time to graph it, absolutely pause it at this point. I'm just going to move right along. So at the bottom of the graph, notice I didn't put arrows on it. The reason there's no arrows here and here is because the graph doesn't continue there. It started at 0, 0, which was 0 seconds and 0 feet in the air. Then it hits the ground right here at 7 seconds. It doesn't continue down further than that because it comes to a stop at that 7 seconds when it hits the ground again. There is no negative height. It doesn't go into the earth. It doesn't go at all. All right, so just a couple more questions building off of that graph, and then we are going to be done for the day. Remember your code word. Hopefully you wrote that down. Okay, so part D says, at what time is the rocket the highest? So think about where it's the highest. It's going to be at that very tippy top point on the parabola right here. But it's not asking you the height. It's asking at what time. Remember, time is your x-axis. It's asking for an x value. So the x value where it's at the highest height, I'm just going to bring this down to show you where it falls. It's right in between 3 and 4. So it's going to take 3.5 or 3.5 seconds before it reaches its highest height. Okay, E, determine the interval where the rocket is falling. I will just walk you through that real quick, but it comes from that week 7 notes that we skipped. So you don't have to worry about this on a test or a quiz. I just don't want to skip it with you guys. So determine the interval when the rocket is falling. Think about the path here. It's going up, and then at this point right here is where it starts to fall. So from 3.5 through, technically the graph goes on forever. If you looked at your calculator, you'll absolutely notice the graph never ends. But remember that idea we talked about where there's no arrow there because it ends when it hits the ground at 7. So the interval where the rocket is falling is from 3.5, the highest point on the graph, or the time when it's at the highest, through when it hits the ground because it stops falling there. All right, so that is the end of the week 9 notes. If you guys have any questions, please reach out to me. I'll even throw my email on here just so you guys have it easily accessible. Remember, my homework key is posted on Blackboard, so practice those questions to prepare yourself for your quiz and reach out if you have any